Hi again, friends. This is part 2 of a video we're doing to design a control panel for my teletype loop infrastructure. The control panel is used to limit the current and monitor the current going through the current loop. It also has provisions for a bypass and makes use of an external loop supply, one that I got that was used by the Navy. This is part 2. Part 1, we assembled all the components, we designed the circuit, and we created a panel and laid it out with a CAD tool, and we submitted it to the manufacturer and got it back and started assembling the panel. In this video, we're going to wire everything up and finally test it. Okay, so I'm at the bench and I'm starting to plan out the wiring. And I discovered one little issue with the way the diagram is, the way the schematic is compared to how we're going to actually wire it up. So I'll just take a quick look at the issue. And the issue has to do with the fuse. So you can see here that the fuse is situated between the jack and the negative of the ammeter. And so let's take a look. This is the fuse. Now the fuse system, the fuse holder I got happens to have already included some leads. Maybe if I'd gotten one with solder-on leads, this wouldn't be a problem. But one of these, as I mentioned, one has to go to the jack. That's not a problem. But the other has to go to the negative of the ammeter. This is the positive, that's the negative, and it doesn't fit. It just won't reach. Now I could get a piece of wire and extend it, but it's a little ugly. So what I instead have done is I've changed the schematic to match what I'm going to build. And here you can see, if this is clear, that I've now just relocated the position of the fuse and the ammeter. So now the fuse is between the rheostat and the positive of the ammeter, and then the negative of the ammeter goes to the loop jack. And so what that allowed me to do is, easily enough, one of these will go to the rheostat, and the other will fit to the ammeter, the positive of the ammeter. And so yeah, that's the change. Let's get this thing built. Well, I've wired it up. Took a bit of time, made a couple of errors, but I'll just scan it here so you can see. I will mention that the wiring will be secured. It is just sort of free form at the moment, and you always want to rather be an inch too long than a millimeter too short. And so everything will be tied together with wire ties, but I just wanted to get it put together to do some very basic tests. All right, so what is the test that we're going to do? What we're going to do, if I can find it, is, of course, can't find it. I'm going to use my lab supply. Now, I can't get 120 volts DC out of this, so the numbers won't exactly work out, but I can crank it up, and the idea is to see how this thing responds. We should be able to get some deflection in the ammeter, and you'll notice here that that I've got the power supply clipped onto the barrier strip, which then feeds that's where the 120 volt power supply will be. So let's see what we can do with this. All right, so we're looking at the right hand side of the power supply. I've got it cranked up to 34 volts, and I'll limit this to that's fine. It will never get up to 80 milliamps, but I'll just leave it at 80 milliamps. So let's first make sure that we've lowered the current, essentially maximizing the resistance of this rheostat. This is minimizing it because we want more current. This is maximizing it, and I had to make sure to wire it correctly that way. All right, so I'm going to flick on the power supply. The power supply is on, and hopefully we'll get some deflection on the meter. Now oh, sorry, I've got to turn this on. This will not light. This is a neon light that's needing about 120 volts or so to light up, but it's in parallel with everything, so it won't interfere. All right, let's increase, nothing. Increase, we're at the max. And oh, I should mention also that I'm using this little plug into the loop jack here to complete the circuit, which emulates the rest of the equipment on the loop, except just without the resistance. But still, this is not functioning. So I know, the obvious. Forgot to put a fuse in. That'll do it. So that's going to keep the circuit open. Let's put that fuse in, and let's do this again. Let me turn the power off, just for safety. Put the fuse in. This is one of the screw top, which I like. Gotta get a little bit of pressure in there. Here we go. Okay. Okay, let's turn this down again. Let's put the power on. Oh, already we can see deflection. And hopefully if I turn this to the right now, we should get more current. Yep, not a lot, but more current. So at least it's doing the right thing in the right direction. And if I switch this off, the power should go off. Now, in reality, that should still measure any current going through this loop connector here, in and out, just in and out, as this is in bypass mode, as you can see. Up is loop supply, down is bypass. But we'll test that. We'll try to test that when we get it into the actual rack. So what are the next steps here? So this seems to be right. I think the next steps here are to connect it to the 120 volt DC supply, the Navy supply, and then test it with the rest of the equipment on the loop. But so far so good. We've tidied things up a little bit. Take a look at the, I've got just some wire ties in there to keep everything a little bit tidy, and so that it doesn't flop around when it's in the rack. And so now I think we're ready to do the next test. To our project here, plus is this one, negative is that one. And so let's turn this on and let's see. Well, I'll tell you what, let's flip this on its back so we can actually see it. Now, a couple of things to note. One, I've got to remember to turn this on. And at 120 volts and only 1.5 k ohms, we should get about 80 milliamps with no equipment plugged in. Of course, the more equipment you plug in, the lower, the lower current that you'll get with the same voltage. And this voltage is 120 volts. All right, so let's turn this on first. Okay, I don't know if you can quite see that, but it is lit up, very dim. And it's got a slight hum to it. Maybe it doesn't know the words, but I'm bummed. Okay, now over to the panel, and let's flip it on and see what we get. I should mention that I still have this shorting plug in here. And there we have it, even at the lowest setting. Okay, so a couple things. One is we've got our nice little, neon bulb lit up to tell us that it's on. And we're getting about 78 milliamps or so. I did check this. It's fairly accurate, within a couple of milliamps, 2 maybe. And then let's increase this, and the current should increase. And we can safely go to 100 milliamps without any kind of damage, because this gauge is up to 100 milliamps. All right, and actually it maxes out at 100 milliamps. So we really can't damage anything, and if we wanted to. And so that's great. So everything's working so far. So the next thing to check is let's get this mounted in the rack, and let's check for to make sure we get down to 60 milliamps when all the equipment's plugged in, and then we'll see if we can also test this bypass function. So we're ready to test, do a preliminary smoke test, and as you can see, I've installed it into the rack just above the jack field and just below 2 terminal units. First thing we need to do is turn on the main power supply. Okay, we'll do that. Oh, sorry. There we go. Hard to see, but it is on. All right, and we've got the new panel plugged into here, into the jack field. It really could be plugged in into any one of these jacks. And that should be all we need to do. We've got a few things plugged in. We've got two teletype machines. And this is for this Navy RAT converter, RIDI converter. And so let's turn it on and see how much smoke we get. All right, well, no smoke yet. I don't smell anything bad. And as you can see, let's see if this adjusts properly. We're lowering it, yep, and we're raising it. Good. So I can get about 70 milliamps to about 55 or so milliamps range, which sounds pretty good to me. And yeah, so nothing has exploded. Okay, so how are we going to test this bypass function? What we're going to do, the purpose of the bypass is, again, if I need to use a separate power supply or a separate terminal unit that includes a power supply like this one, I can throw this into bypass mode. So what we're going to do is we're going to switch this off to bypass. You see the current goes down. And we're going to plug in the ST-6. This is the plug for the ST-6 into the jack field. And then we're going to turn on the ST-6, and hopefully this will all work and we won't get any smoke. All right, so this is now supplying power to the teletype machines. And as you can see, it's also displaying the current for the teletype machines. But it is not now affected in any way by this rheostat because it's all been bypassed. So this is one way I can do it. I got to admit, it's a little scary because, you know, if I were to throw this bypass switch up, I'd be getting like 240 volts total on this loop, and you know that's likely to destroy equipment. So I think what I'm instead going to do, I can use it, but I'm going to plug in and unplug the ST-6 manually, make sure that there's no risk of me putting them on at the same time. All right, so the last thing to do now is to test the teletype machines. What I decided the easiest thing to do is to make use of this teletype test machine, which allows you to set up two different characters, or it has built-in sentence. If you can see it up here, I probably cannot. Let me zoom in a little. So this is the right-hand side of this is the business end. And so, you know, you can set up, these are RYs, you can see alternating bits. But I'm going to use the sentence, which is the quick brown fox sentence. And what you do is you hit this release button, and it'll run it once in burst mode or continuously in continuous mode. Okay, so how do we get this integrated with the whole setup? Let's zoom out again here. Okay, so what we're going to do is, as you can see, there's this output cable from the unit, and we're going to plug it into really anywhere in the, well, let's turn it on. Okay, and we plug it in anywhere into the jack field. And what we're going to do is we're going to hit this release button, and then I'll zoom in. You can see the meter moving around. All right, well, you might be able to also hear that. That's the teletype machine doing its thing. And let's take a look at this. So this is alternating, well, we just did one sentence. This is alternating between closed circuit, which is 60 milliamps, and open circuit, which of course is 0 milliamps. Let's tweak that just a touch. And that's what you get. Let's release it again. Great, well, and no video about teletypes is complete without some video of the teletype. Let's take a fast look. All right, well, this concludes the project of creating this teletype control panel to adjust the current for use with this Navy teletype power supply. And it allows me to use equipment and not have to be forced to use the ST6 for the power supply. All right, thanks a lot.